Hello to all, this is Dr. IJR initiating online lecture series on operations research. Today we are going to discuss about restriction case of assignment problem. So in this lecture we are going to learn about how to deal with the restriction type of problems under assignment. Let us start with one problem. Here in this problem, so 4 workers and 5 machines are given. So under this, if you observe the matrix of this table, so we can see that there is a one restriction like and another restriction. So two restrictions are there. So what is the first restriction is W2 M3. That means what is the meaning of W2 M3 restriction is W2 can't be assigned to machine 3 or machine 3 can't be assigned to the W2. In the same way, W3 M1. What is W3 M1 is the worker 3 can't be assigned to the M1 and M1 can't be assigned to the worker 3. So this is the restriction. So we don't use any numbers. So we have to use the as it is manner. But sometimes we can write different symbols other than the number. So let us start with how to solve this problem. But before starting of any of the assignment problem, first we may check that whether it is a balanced problem or unbalanced problem. So how can we check that whether it is a balanced or unbalanced is simply number of rows is equal to number of columns. Here, how many number of rows? 4. Columns are 5. That means 4 not equal to 5. So we can say that it is unbalanced problem. So we may convert this unbalanced problem to the balanced problem by simply add 1 dummy row, because rows are less and columns are high. So we have to equate the rows with the columns. That is the reason we have to add one dummy row like this. W5 is its dummy row and take all values are 0 because dummy did not have any values. That's the reason we have to take zeros. The form of this table like this. So in this case, how to solve this matrix is, please see my previous videos on the non-degeneracy case and degeneracy case. So let us start with how to solve this is. First one is, you have to read this note. If all rows and columns are already having at least 1 0, in that case don't require step 1 or step 2. If you see this particular matrix, all columns are having zeros, but all rows did not have any zeros. That's the reason we have to do this one, step 1, row minimum. So identify the minimum number of each row, 11, 11, 9, 9 and 0, and lessen this minimum number from all the elements of the respective row. So we can get one matrix and do the process. Please visit again my previous videos, and the final form of this particular matrix is like this. And if you see this matrix, all rows, all columns are having zeros, so we can directly do assignment. So how to do assignment is row process and column process. First one is row process. So first concentrate on single zero, only 1 0, and assign that. If you see this, the first one W1, only 1 0 is there, we can directly assign this one and cancel the remaining 0 of that particular column, because already we assigned W1 to machine 1. So that means machine 1 is not idle, is not available to the W5. That's the reason we strike off this particular 0. And see the second row, there are 2 zeros are there. So we leave that particular row, we can deal that particular row after completion of all the process. W3, there's only 1 0 is there, we can directly assign. And see M5, we're already having another 2 zeros, we can simply strike off that particular 0. W4, again 1 0 is there, we can directly assign and strike off the remaining 0 of the particular column. And W5, again there are 2 zeros are there, so that means row process completed. Now we can do the column process. So again same thing, if column contains only 1 0, then assign immediately. So M1 already assigned, M2 only 2 zeros are there, M3 only 1 0, we can directly assign this one and strike off the remaining 0 of the particular row. And if you see there is only 1 0 is left over, so we can directly assign here W2 M2. And so all there are no leftover zeros are there, and check that whether this problem is a degeneracy or non-degeneracy by means of number of rows is equal to number of columns is equal to number of assignments. So number of rows is equal to 5, number of columns 5, and number of assignments again 5. So it is referred as non-degeneracy problem. Non-degeneracy. That means we reach to the optimal solution. So once we confirm that we are getting an reach to the optimal solution, so we have to take the original table. What we are having the original one given in the problem. We have to take that particular table like this, and this yellow color shades or assignments. This is the original table. So W1 can be assigned to the M1, and what is the total time? 11 hours. W2 to M2 again 11 hours. W3 M5 9. W4 M4 it is 9, and W5 M3 0. So total is equal to 40 hours. So this is the optimal solution. So this is the actual sequence or accurate sequence or the best sequence of this particular problem. So by using this sequence, we can get the entire work within the 40 minutes, 40 hours. If other than this sequence, so we can get more than 40 hours, so that is not an acceptable one. So 40 is the optimal solution. So this is the way we can solve this type of assignment problem. So now we use Hungarian. So for any type of assignment problem, we have to use Hungarian method only. So it is one of the best and accurate methods of the assignment. So I hope all of you understand about the restriction. So don't worry about the restriction and don't give so much of importance to the restriction point of view. Restriction is restriction. So that means we can't touch that restriction. So this is the way. I hope you can enjoy this video. Thank you. Thank you for watching.